Okay, so good afternoon, friends. In the previous session, we have discussed about decision tree algorithm. So, anybody have any doubts regarding that algorithm? Okay, hoping that the concepts were clear and you don't have any doubts in the previous topics. So, let us move on to the next topic in the flow. So, the next thing that we are about to discuss is random forest regression. Okay, so this is the algorithm which is comes next to the decision tree algorithm. As so this algorithm is considered as the extension of decision tree algorithm, because so as the name itself says us, decision tree, it going to generate a single decision tree which will helps us to make the decisions. Okay, and this is a random forest in a sense many trees. Okay, so it will going to generate multiple trees, multiple decision trees, so in order to make the decisions. Okay, so that's how this algorithm is making the difference and extension for the previous algorithm. Okay, so like why this has come to an existence, why it is introduced means, so what happens if we have used a decision tree and that one decision tree can make mistake, right? So if that decision tree is makes mistakes, then we probably get the wrong results, right? So if we don't aware of any accuracies and all, so we might get mistakes, we might get wrong results. So for that purpose, what happens, what if we combine many trees and take the majority vote? Okay, so that's how that random forest is going to work. So random forest will going to have many decision trees, will going to create many decision trees, and along with that it is going to take the majority vote. Okay, so majority vote it will going to consider, and it will give you the final result. Okay, so that's how it is usually called as the extension of the decision tree algorithm. Okay, so here we are going to have like multiple decision trees to be constructed from this algorithm, and that those decision trees only will be generated by using the part of the data set, not from the entire data set. So it will going to use part of the data set, and thereby it will going to create multiple decision trees. Okay, and finally it will going to give you the class based on the majority vote. So like this it will going to, just a second. Okay, so this is a training data set, entire data sets, as we are going to use in the previous problems. Like, so in the previous problems, what we are going to use, we have we'll usually consider entire data set at once, and for all the rows, all the columns which is present in the data set, we are going to consider every sample, and we used to have the trees, right? But here what happens, it will take the random number of samples, okay, and create a tree like this. Okay, and next part will be the next set of random values. Okay, so next set will be the next set of random samples from the data set. Okay, so likewise, so as many as mentioned trees is created based on the numbers given by the user. ಓಕೆ. ಸೊ ಡೆವಲಪರ್ ಹತ್ರ ಯೂಸರ್ ಆಗಿರ್ಬೋದು ಎಷ್ಟು ನಂಬರ್ಸ್ನ ಕೊಡ್ತಾರೆ ಅದರ ಬೇಸ್ ಮೇಲೆ ಸೊ ಎಷ್ಟು ಟ್ರೀಸ್ ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಆಗಬೇಕು ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿರ್ತೀವಿ. ಸೊ ಅದು ಬೇಸ್ ಮೇಲೆ ಸೊ ದ ನಂಬರ್ ಆಫ್ ಟ್ರೀಸ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ಸ್ಟ್ರಕ್ಟೆಡ್ and by taking a part of the data set, okay, and each one of that will give you the specific decision, and we will take the majority decisions, okay, and conclude to one. Okay, for example, so if I have an example of fruits, okay, if I have an example of fruits like this, so this is my entire data set. Okay, so what happens, I'll take some fruits on one basket and some fruits on one basket, some fruits on another basket, and let my decision tree consider is built, okay, and let it decides what that particular fruit will be. Okay, so it will just going to decide it like a class A, that is apple. Okay, so another decision tree will take another set of fruits and it will going to decide what it will be. So that also giving you the result like apple. Okay, next last one will be the class B, that is banana. Okay, so likewise we can have different decisions from different decision trees based on the part of the data set that it is considered. Okay, so, and what we are going to have, so we are going to collect all these outputs from the each and every decision tree, and which class is getting more votes. Okay, so that class will be given as the final result like this. Okay, so this is how decision tree is going to work. Okay, so it is also called as bootstrap aggregation or bagging, I can say. For example, like imagine you are suffering from any disease, and you have suffered like you have faced some symptoms, right? So like cough or something, so you just instead of going to one doctor, you'll ask for 10 doctors, right? You'll search for the browsers, you'll go for visiting the doctors, or you go for take an appointment online, and you'll just ask them. So just for the sake of like precautions, like in order to avoid any bigger thing to happen, right? So out of 10 doctors, so 7 doctors will say that this is the flu symptoms, so you better go to take this and this test and so on. So okay, so what do you do? So you trust the majority, right, before taking the important decisions, right? In the similar fashion, this is exactly how random forest works. So before taking the important decisions, it will ask for the majority. Okay, so if the majority people are saying the particular class, then it will going to decide the particular class as an output. Okay, so that's how random forest going to work. Okay, but while creating the decision tree, it will exactly use the same thing as we did for the decision tree. Like it will going to use that entropy, it will going to use the decision Gini index, it will going to use the information gain for building that tree before deciding the particular feature as the root node or intermediate node or the leaf node. So it will going to find out, it will going to calculate, so what is the entropy of each and every feature, what is the information gain from each feature. So it will going to calculate, and it will going to identify so which feature has to be in the next, okay, which feature has to be at the top, which has to be at the intermediate node. So likewise it will going to decide, and the next level after constructing the decision tree, so all the outputs will be considered by the one single person, and that person will going to consider which class is getting the majority votes. So it will just consider, declares that as the result. Okay, so that is how random forest works. And what is the advantage from this random forest algorithm? Okay, so what is the disadvantages of the decision tree algorithm? Let us first see that. After that we came to know, we come to the point of advantages from this random forest. Okay, so what happens when the decision tree works? So the main thing, the main problem from the decision tree algorithm is that this algorithm is going to overfit so easily that as it will going to consider which each and every data sample. Okay, so since it is considering each and every sample values and each and every column row values, so there may be a chance of overfitting, like it is more prone to overfitting. the decision trees. Okay, so for that purpose, to avoid that thing, and since the decision tree is also very sensitive to small data changes, if we change any small information, small minor changes to the data set, so the entire tree may take the deviation, right? Excuse me. So for that purpose, what happens, we have to be very careful while making the decisions. And also, the one more disadvantage for the decision tree is, so larger trees can become more complex, and navigate, like tracing the path is very becoming complex and for time consuming also. So to avoid these kinds of disadvantages from the decision tree algorithm, so this random forest algorithm is get introduced. Okay, so what happens for these things when we use random forest, so it will give you the high accuracy, and it will reduce the overfitting, since like unnecessary branches is also avoided, like random data has been splitted. So if it is the having a issues, if it is giving the problem, so that affects that tree only. And if that tree is giving the wrong result, then that means that is not the like even, then it will be in the minority group, and that will not be considered. Okay, so thereby it avoids confusions and reduces the overfitting issues. Okay, and even it will work well with a very large data set. So what happens when we are going to consider the decision trees, so decision tree considers entire data set all at once. Okay, so then it might be very good. So it might be very difficult for constructing the trees by the decision tree algorithm. So when in such places, in such cases, if we use random forest algorithm, so then it would be easy for them to uh, build the decision tree, as it is taking only a part, not the entire data set. So it is, so thereby it will work well with the large data set also. Okay, so that's how random forest algorithm going to uh, be worked. Okay, so let's just you can just make a note of these points. So these are the advantages from the random forest algorithm. So these are the disadvantages which will overcome here. Okay, so let us just take a simple data set, and we'll work with the random forest algorithm. Okay, so let us take a simple student past data set. So consider this is the simple data set. So here input features will be hours and sleep, and output will be pass or fail. Okay, so what we are going to do now, so just implement this data set. Okay, first we need to import as usual pandas as pd, and import from Scikit-learn dot ensemble. So this is the place where random forest classifier is located. Okay, so along with that we can also use import Matplotlib dot pyplot as plt. Okay, so let us just take a basic libraries. Okay, so first we need to import all the necessary libraries. So next create the data set. So my data set is equal to, so I'll just create it. I'll take the help of AI tool and create the data set. Verse sleep and result. So these are the values so that I have stored. So let me create a data that is equal to pd dot data frame of data set. Okay, so this is my data set. So I have a spell mistake here. Okay, successfully imported the libraries. So next we have to create the data set. Okay, so next it is converted into a data frame. So in order to work on this, okay, so Pandas is used for the data set operations and Scikit-learn is used for machine learning algorithms. Random forest classifier is the algorithm that we are going to use. Okay, so here the data set contains hours of studied and number of sleep hours and what is the result, pass or fail. Okay, so then we are going to split up into x and y. So our x is equal to data of, it is hours comma sleep. Okay, so based on hours and sleep we have to predict whether he is going to pass or fail in the exam. Okay, so data of result. Okay, and after that we have to go for our train and test split. So from Scikit-learn dot model select import train test split. So x train comma y train comma x train x test y train y test. We have to give it in that order. X test comma y train y underscore test. So in the same order we have to give the variables, because the train test split method will give you the results in that format only. So to this we have to pass the independent and the dependent variable set. Okay, also mention the test size or train size. So I'll mention here trains test size like 20%. Okay, so just run this. Okay, so my split up is ready. Now it's time to select the model. Okay, here we have to mention how many number of neighbors that, sorry, how many number of trees that I wanted to build from this algorithm. So as I said in while explaining about the algorithm, so this is going to build a number of trees as per mentioned by the user or the developer. Okay, so rest mention ಮಾಡಿರ್ತಾರೆ ಅಷ್ಟು trees develop ಆಗುತ್ತೆ. Let us consider this for 100. Okay, so let us just train this model classifier dot fit of x train comma y underscore train. Okay, so model is successfully trained. Okay, so this is how we can train the model. So next we shall move on to the predicting the accuracy. Okay, find out the accuracy of the model. So ypred is equal to accuracy score of white test comma white bread. Okay, oh sorry, it is actually, so before that we have to predict the, so y underscore spread is equal to, so we have to predict the value, classifier dot predict of x underscore test. For the testing results we have to find the predicted results. Okay, so here from Scikit-learn dot metrics import accuracy score, so we got 100% accuracy. Okay, so we can vary this size and we can check out the accuracy results. Okay, so this is how we can train the model and we can predict the results and check the accuracy. Okay, you can also change the number of trees here. Okay, so this also affects the accuracy of the model. Okay, so this is how we can implement so this random forest algorithm. Okay, okay, so this is the method. Okay, so this is how random forest algorithm going to be implemented. First we have to import the libraries, next create the data set, next splitting up the data set into x and y, and after that we are going to train the random forest model, and we will make 10 decision trees for now. Okay, and after that we'll make the predictions for the test results. Okay, and we can just simply find out the accuracy of the model. So if you find the accuracy of the model, you can just get to know that, so this what is the accuracy. So for this data set we got to know, so this will be 100% accuracy. Okay, so now we can just deploy it by asking it result for new sample. Okay, so it is classifier, so it is predicted as 1. Okay, so that means it will go into 5 hours of study and 7 hours of sleep, so usually pass. Okay, so the result pass anta bartade. Okay, so you can just give for 6 hours of study and 7 hours of sleeping will pass, 2 hours of study, 7 hours of sleeping, so we will fail. Okay, the student might get failed. So that is how you can have different problems that can be solved by using random forest algorithm. Okay, so and meanwhile we can also check for the which feature is contributing much for predicting the results. Okay, so for that purpose we can take the help of method called feature importances. So it will give you like, now what is the importance, like mainly you can observe here, first value is for number of hours he used to study, so next is number of hours he used to sleep, right, and which is contributing much on predicting the results. Okay, so here you can see, observe, this is the contribution for the result by study hours, and next is what your sleep hours. So which feature is more important now, so for our data set, so since the value is more for hours of study, so it is giving more results. Okay, so ಇದು ನಮಗೆ ತುಂಬ ಅಫೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೆ ರಿಸಲ್ಟಿಗೋಸ್ಕರ. ಸೊ irrespective of the number of hours which is used for sleeping, so you have to contribute, if you contribute more on studying, in spending more time on studying, so then you can get the better results. So that is what the conclusion that we can got from the model. Okay, so finally, so random forest uses many trees for making the decisions. It will going to consider the majority vote from the different trees, all the trees which is generated, and which class is getting the majority votes, that class will be decided as the output. Okay, it will combine all the predictions from the each and every decision trees, and even it is more accurate also when it is compared to the single decision tree algorithm. And this algorithm can also be used for both the purpose like classification and regression. Okay, so that is how the random forest algorithm going to work. Okay, so do you have any questions? Understand? ಅರ್ಥ ಆಯ್ತಾ? Okay, good. So fine. So this is how random forest algorithm going to work. So let us move on to the next algorithm called as naive Bayes. Okay, so since we have already discussed deeply with the decision trees, we have random forest is just a simple extension of the decision tree. Okay, so that's why it is finished so early. Okay, so next it is about the naive Bayes algorithm. Okay, so before getting into the next algorithm, so let me clear one thing. So please practice on the different data sets or like work on the different algorithms. So if you are solving, if you are able to solve a single regression algorithm, so try for different regression algorithms. Don't stick for one algorithm only. So try for applying different regression algorithms so that you can get the better accuracy. So you can compare different algorithms effects on the particular data set. So you can get to know which is the suitable algorithm for my data set. And for while solving the classification problem also, so try for the different classification algorithms to run on the same data set, say for the same problem. So if you get the different accuracies, just check out the accuracies. So if your chosen model is wrong, so it might not get the better accuracy when you are using multiple algorithms for on the same data set. So then you can check for the working and the suitableness of the comfortableness of the algorithms with the data set. So if it is comfortable, if it is better, if it is the best logic for predicting the answer, so then you can get the better accuracies than with the previous selected one. Okay, so just implement with the different algorithms. Okay, so now let us move on to the naive Bayes algorithm. So what is actually naive Bayes algorithm? Have you heard this word, naive Bayes? ಕೇಳಿದ್ದೀರಾ? ಏನಿರ್ಬೋದು? So you probably heard it in maths. ಕೇಳಿದ್ರಾ? ಹೇಳಿ, ಏನಾದರೂ ಕೇಳಿದರೆ ಇಂದು ಹೇಗೆ ವರ್ಕ್ ಮಾಡುತ್ತೆ? Okay, so let me just so I hope you have just remembered, like it is not proper. Okay, so naive Bayes ಎಲ್ಲೋ ಕೇಳ್ದಂಗಿದೆ, ಎಲ್ಲಿಂದ ನೆನಪಾಗ್ತಿಲ್ಲ. ಸೊ ಎಲ್ಲಿಂದ ನೆನಪಾಗ್ತಿರಲ್ಲ. ಓಕೆ, ಸೊ ಇಟ್ ಈಸ್ ಜಸ್ಟ್ ಬೇಷಿಯನ್ ಥೇರಮ್ ಅಥವಾ ಬೇಷಿಯನ್ ಲಾಜಿಕ್ ಅಥವಾ ಅಲ್ಗಾರಿದಮ್ ಅಂತ ಏನಾದ್ರು ಕೇಳಿರ್ತೀರ. ಸೊ ಬೇಸ್ ಥೇರಮ್ ಅಂತ ಕೇಳಿರ್ತಾರಲ್ವಾ ಮ್ಯಾಥ್ಸಲ್ಲಿ. ಸೊ ಸೇಮ್ ಲೈಕ್ ದಟ್. ಸೊ ಇಟ್ ಈಸ್ ಅ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಟೆಕ್ನಿಕ್ ವಿಚ್ ಇಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಬೇಸ್ಡ್ ಆನ್ ಬೇಸ್ ಥೇರಮ್ ವಿತ್ ಆನ್ independence assumption among the predictors. Okay, so in simple terms we can say that the naive Bayes algorithm so find out the probability. Okay, in short, okay, probability of appearing the one class for the particular set of values. Okay, so which class is getting the more probability, so that will be identified as the result, and that will be given from the algorithm. Okay, so that is how a naive based algorithm going to work. So in simple terms we can say let me just have a screenshots. So it is in simple words you can say it like this is a, simple Bayes algorithm. Okay, so based on Bayes theorem. Okay, and it is used purely for the classification problems. Okay, so naive Bayes classifier is one of the most simple and effective classification algorithms which helps you to build the fastest machine learning models that can be given with the quick decisions. Okay, it is one of the fastest algorithm. So when it is compared with the other algorithms, so that is why it is most standardly used algorithm for classification problems. So previously ನಾವೇನು algorithms ಹೇಳಿದ್ವಿ, so explain ಮಾಡಿದ್ವಿ, discuss ಮಾಡಿದ್ವಿ. So those are all the algorithms which can be used for both the purpose. So there are certain algorithms, some set of algorithms are present which can be used for purely solving the regression algorithm. Those cannot be used for solving the classification algorithms. But there are some set of algorithms which can be used for both the purpose, for solving the regression problems also, for solving the classification problems also. And we have some set of algorithms which is purely used for the classification algorithms. So just like k-nearest neighbor algorithm and what is that, naive Bayes algorithm. Okay, specifically naive Bayes. Okay, so most commonly standardly used algorithm and the one of the easiest algorithm and the fastest working algorithm also. So this can be used for solving the classification problems based on the Bayes theorem. So what does that Bayes theorem says? So here it is. So Bayes theorem says like probability of A to the space B is equal to probability of B to the A into probability of A divided by probability of B. So here this is not this is just a simple equation. So when you see this you might not get it properly, right? So this is the standard equation that is going to be worked at the back end. Okay, so let me just explain it with an example, then you might get the clarity. Okay, so let me have an example for the naive Bayes algorithm. Okay. So for example, if fruit is red, round, and is about 3 inches wide. Okay, so consider, so there's a fruit which is red in color and round in shape and about it will be 3 inches of wide. Okay, so we might call it an apple, right? So even if these things are related and each one helps us to decide it, like its probability an apple. Okay, so that's why it is called as naive. Like ಇದು ತುಂಬ ರೆಡ್ ಇದೆ, ರೌಂಡ್ ಆಗಿದೆ, 3 inches ವೈಡ್ ಇದೆ ಅಂದರೆ ಸೊ ನಮಗೆ ಏನೇನು ಥಿಂಗ್ಸ್ ಎಲ್ಲ ರಿಲೇಟ್ ಆಗುತ್ತೆ, ಯಾವ ಫೀಚರ್ಸ್ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ, ಇವೆಲ್ಲ ನಮಗೆ ಅದು ಆ್ಯಪಲ್ಲೇ ಇರ್ಬೋದು ಅಂತ ಡಿಸೈಡ್ ಮಾಡೋದಕ್ಕೆ ಪ್ರೊವೋಕ್ ಮಾಡ್ತಾ ಇದೆ ಅಲ್ವಾ. ಸೊ ನೀವು ಜಸ್ಟ್ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಸೊ ಫ್ರೂಟ್ ಕಲರ್ ರೆಡ್ ಇರುತ್ತೆ, 3 inches ವೈಡ್ ಅಂದರೆ ಸ್ವಲ್ಪ ದೊಡ್ಡದೇ ಇರುತ್ತೆ. ಆ್ಯಂಡ್ ಇಫ್ ಇಟ್ ಈಸ್ ಆಫ್ ರೌಂಡ್ ಕಲರ್, ಸೊ ವಿ ಮೈಟ್ ಲೈಕ್ ಆ ಕಲರಲ್ಲಿ ಬರೋ ರೆಡ್ ಕಲರಲ್ಲಿ ಬರುವಂಥ ರೌಂಡ್ ಶೇಪಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ ರೌಂಡ್ ಶೇಪಲ್ಲಿ ಬರುವಂಥ ಫ್ರೂಟ್ಸ್ ಅಂದರೆ ಯಾವುದಿರುತ್ತೆ? Okay, so red color ಬರುವಂಥ ಫ್ರೂಟ್ಸ್ ಅಂದರೆ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ವೆರಿ ಫ್ಯೂ ಫ್ರೂಟ್ಸ್ ಲೈಕ್ ಚೆರಿ, ಸ್ಟ್ರಾಬೆರಿ. ಸೊ ಈ ಥರ. ಸೊ ಅದರಲ್ಲಿ 3 inches ಆಫ್ ವೈಡ್ ಅಂದರೆ ಇಟ್ ಮೈಟ್ ಕ್ವೈಟ್ ಬಿಗ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ನಮಗೆ ಗೊತ್ತಿರೋಂಥ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಪ್ರಕಾರ ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಆ್ಯಪಲ್ ಓನ್ಲಿ. Okay, so that is why it is called as naive. Naive means like probability we are going to consider. Like how often we have seen. So those are all the times we have observed this. With these features there will be a one fruit that is apple only. Okay, so if you have seen like other fruits also, then you might get confusions. Okay, so this is how a naive Bayes algorithm going to work out. So many times what is the maximum things which makes you to see one decision? Okay, so ಒಂದು ಡಿಸಿಷನ್ ಬರೋಕ್ಕೆ ನಿಮಗೆ ಯಾವುದು ತುಂಬ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗಿ ಹೇಳ್ತಾ ಇದೆ, ಯಾವ ಡಿಸಿಷನ್ಗೆ ನಿಮಗೆ ತುಂಬ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡ್ತಾ ಇದೆ, ಒತ್ತು ಕೊಡ್ತಾ ಇದೆ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದೆ, ಪ್ರಾಬಬಿಲಿಟಿ ಕೊಡ್ತಾ ಇದೆ, ಕನ್ಸಿಡರಿಂಗ್ ಆಲ್ ಅದರ್ ಫೀಚರ್ಸ್. ಸೊ ದೆನ್ that class will be considered as the result. Okay, so let me just have another data set. we have used previously one data set, right? So let be my question is, so player will play, okay, so will player play the game if the weather is sunny. Okay, so ಅವ್ರು ಹೋಗ್ತಾರ, ಇದು ನಮ್ಮ ಕ್ವಶನ್. ಸೊ ಪ್ರೀವಿಯಸ್ಲಿ ನಮ್ಮ ಪ್ರಾಬ್ಲಮ್ ಏನಾಗಿತ್ತು, ಸೊ ಬೈ ಕನ್ಸಿಡರಿಂಗ್ ದ ಓವರ್ ಕಾಸ್ಟ್ ಔಟ್ಲುಕ್, ಹ್ಯೂಮಿಡಿಟಿ, ವಿಂಡ್ ಆ್ಯಂಡ್ ಟೆಂಪರೇಚರ್, ವಿ ಹ್ಯಾವ್ ಟು ಪ್ರೆಡಿಕ್ಟ್ ವೆದರ್ ದ ಪ್ಲೇಯರ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರೆಡಿಕ್ಟ್ ದ will play the game or not. Okay, so now my question is, player will play if the weather is sunny. Okay, so if we go or not. Okay, so we have to find it out using the same data set that we are going to consider. Okay, so let me just have it here. Okay, so it's the same 14 data set but considering only one feature here. Okay, so we are going to find out like how probable it is when the weather is sunny. What is the probability of S? When the weather is sunny, what is the probability of no? So that we have to consider first. Okay, so how we are going to calculate it? So we are going to consider the frequency table when the weather is overcast, when the weather is rainy, and weather is sunny. Okay, so we are going to calculate it. When the weather is overcast, so probability of S is 5 out of 10, probability of no is 0 out of 4. Okay, so likewise rainy and sunny. Okay, and we are going to construct the likelihood table also on the weather condition. So what is the probability of no versus S? Okay, first we are going to prepare a frequency table and we are going to extend it with the likelihood, that means probability. Okay, so based on this, okay, so we are going to find out what is the probability of S when the weather is sunny. Okay, so applying the Bayes theorem. So here our A is S and B is sunny. Okay, so when the weather is sunny, what is the probability? Excuse me. Okay, so here when the weather is sunny, so what is the probability of S? So that we are going to consider first. So according to the equation here, in the equation ಪ್ರಕಾರನೇ ಹೋಗ್ತೀವಿ. Okay, so probability of sunny to S, probability of S to probability of sunny. Okay, so probability of sunny to S is what? Sunny to S is, come on, 3/10. Sunny to S, 3 over total S irodu 10. Okay, so it is 3/10 total S to overall S. Yes, so it is 3/10, 0.3. Probability of sunny only, like means overall value, it is 0.35. Total sunny overall data set 14 samples ಅಲ್ಲಿ sunny ಇರೋದು 5. ಸೊ ಅದನ್ನು ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಓಕೆ, ಆ್ಯಂಡ್ ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಎಸ್ ಓನ್ಲಿ ಓವರಾಲ್ 14ಅಲ್ಲಿ ಬರೀ ಎಸ್ ಅಷ್ಟೇ ಎಷ್ಟಿದೆ, 10 ಅಂದರೆ 0.7. ಓವರಾಲ್ 14 samples 10 times we played for, like that person had played for game. ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊತೀವಿ. ಓಕೆ, ಸೊ ದೀಸ್ ಆರ್ ದ ವ್ಯಾಲ್ಯೂಸ್. ಇದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ವಿ ಗಾಟ್ ಟು ನೋ 0.60. Similarly, we want to calculate for no also. So we got to know the value is 0.41. So which is getting the highest value? Probability of S is more than probability of no. Okay, so that's why we have decided that on the sunny day, player will go to play the game. Says this statement is correct. Okay, so this is how Bayes algorithm going to work out. It will going to find out the probability of particular output category to the space, entire space with the entire data set. Okay, how often it is yes, how often it is no. Okay, when considering the particular condition. Okay, so that is how Bayes algorithm going to work. Okay. At the back end. Okay, so same thing we can apply it for the Python also. In the ಅದನ್ನು ಪೈಥಾನಲ್ಲಿ ಕೂಡ ನಾವು ಅಪ್ಲೈ ಮಾಡ್ಬೋದು. Okay, so that thing I'll show afterwards. Okay, so this is how naive-bayes algorithm going to work. It will going to use the Bayes theorem or Bayes equation ಅಂತ ಏನಿದೆ. ಸೊ ಇದನ್ನು ಮೇನ್ ಆಗಿ ಇದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಇಟ್ ಗೋಯಿಂಗ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಈಚ್ ಅಕರೆನ್ಸಸ್. Okay, so then it will going to find out whether decision is yes or no. Okay, so then coming to the what are the advantage from this naive-bayes algorithm then. Okay, so as we said with the previous, it is very easy and fast to predict since we are considering like only the probability, not with respect to any other features. Even the calculations is also very simple. We'll just taking the ratios, we'll just taking the division and basic maths operations here, right? So the calculations is also very simple, right? So it is easy and fast to predict the class of the data set. Okay, so and it also performs well for multi-class predictions. If you are using not like just a binary class on yes or no anta ashthe alla, so if you are predicting more than 2 class also, it is good and it will going to predict it well for the multi-class predictions. Okay, so even when the like it builds, it works on the assumption basic on, it is completely based on the assumption like, so there is a independence, there is no dependency between any of the features, there is no contribution, there is no dependency between one feature to another feature. So that is why it is not going to remember, like memory is not going to remember other features when with respect to this existing feature also. So that is why without bothering about the other features, it simply calculates its own way. Okay, and that's how the classifier performs better compared to other machine learning models like logistic regression or decision trees, and it also requires the very much like less training data for training purpose and for giving the better results also. Okay, so let us just, but coming to the limitations or the disadvantage of this algorithm. So let me just have points clearly on the advantages or pros, you can say. Okay, so it is very easy, it is very fast. Okay, so easy to understand, fast to implement, and it is the better model compared to other models like logistic regression, so decision trees and all. Okay, so when and other other advantages are like it what's other point we have. Okay, so it performs well for multi-class classification. So more than 2 classes also it can perform. Okay, coming to the cons then if coming to the cons, if categorical variable has the category which was not observed in the training data set, like if categorical data ಅಂದರೆ categorical variable ಯಾವುದಾದ್ರೂ ನಾವು ಯೂಸ್ ಮಾಡ್ಕೊತಾ ಇದ್ವಿ ಅಂದರೆ, ಸೊ ಅದರಲ್ಲಿರುವಂಥ ಯಾವುದಾದ್ರೂ ವ್ಯಾಲ್ಯೂ ಏನಾದರೂ ನಮಗೆ ಟ್ರೈನಿಂಗ್ ಡಾಟಾ ಸೆಟ್ಟಲ್ಲಿ ಎಲ್ಲೂ ಕಾಣಿಸ್ಲಿಲ್ಲ, ಸಿಕ್ಕಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ, ದೆನ್ ದ ಮಾಡೆಲ್ ವಿಲ್ ಅಸೈನ್ 0 probability and will be unable to make the predictions. Okay, ನಮಗೇನಾದ್ರು ಹೊಸ ವ್ಯಾಲ್ಯೂ ಬಂತು, ಹೊಸ ಥರ ವ್ಯಾಲ್ಯೂ ಬಂತು ಅಂದರೆ, ಸೊ ಪರ್ಟಿಕ್ಯುಲರ್ ಫೀಚರಲ್ಲಿ, ಸೊ ಆವಾಗ ನಮಗೆ ಅದು ಪ್ರಾಬಬಿಲಿಟಿ ಬೇಸ್ ಮೇಲೆ ಆಗಿರೋದ್ರಿಂದ ಕಂಪ್ಲೀಟ್ಲಿ naive-bayes ಅದಕ್ಕೆ 0 probability, ಬಿಕಾಸ್ ಇಟ್ ಹ್ಯಾಸ್ ನೆವರ್ ಸೀನ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂ ಇನ್ ದಟ್ ವೈಲ್ ಟ್ರೈನಿಂಗ್ ಆರ್ ವೈಲ್ ಟೆಸ್ಟಿಂಗ್. ಓಕೆ, ಸೊ ಆವಾಗ ನಮಗೆ ಸ್ವಲ್ಪ ಇಶ್ಯೂ ಬರುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ಆಫನ್ ನೋನ್ ಆಸ್ 0 frequency ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಸೊ this is what the con of naive-bayes algorithm. So but to solve this we can use the smoothing technique. So one of the simplest smoothing technique called as the Laplace estimation, so we can use for avoiding this technique. Okay, so let's not bother much about that thing for now. Okay, so let's see it in the future. Okay, so that is what the disadvantage of the like a naive-bayes algorithm. Okay, so if any value which was not observed in the training data set, so ದೆನ್ ಒಂದು ಟ್ರೈನಿಂಗ್ ಫೇಸಲ್ಲಿ ಇಲ್ದೇನೆ ಇರುವಾಗ ಯಾವ್ದಾದ್ರು ಹೊಸ ವ್ಯಾಲ್ಯೂ ಬಂದಿತ್ತು ಅಂದರೆ ಸೊ ದೆನ್ ದಿಟ್ ವಿಲ್ ಅಸೈನ್ ಅ 0 ಆ್ಯಂಡ್ ವಿಲ್ ಅನೇಬಲ್ ಟು ಮೇಕ್ ದ ಡಿಸಿಷನ್ಸ್. ಝೀರೋ ಪ್ರಾಬಬಿಲಿಟಿ ಅಂತ ಕೊಟ್ಬಿಟ್ಟು ಸೊ ಅದನ್ನು ಏನು ಮಾಡುತ್ತೆ, ಡಿಸಿಷನ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಅದು ಯಾವ ಕ್ಲಾಸಿಗೂ ಸಂಬಂಧಪಟ್ಟಿಲ್ಲ ಅನ್ನೋ ಥರನೇ ಕೊಟ್ಬಿಡ್ತೇವೆ. ಬಿಕಾಸ್ ಝೀರೋ ಪ್ರಾಬಬಿಲಿಟಿ ಅಂದರೆ ವಿಚ್ ಇಸ್ ದ ಲೀಸ್ಟ್ ಒನ್, ಸೊ ವಿಚ್ ಇಸ್ ನಾಟ್ ವಿಚ್ ಇಸ್ ನಾಟ್ ಟುವರ್ಡ್ಸ್ ಎನಿ ಆಫ್ ದ ಡಿಸಿಷನ್ಸ್. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಓಕೆ. ಸೊ ಆನ್ ದ okay, so that is one disadvantage. So and another disadvantage, so as I said, this algorithm will going to work based on the assumption like, so it thinks of all the features are independent. Okay, so it thinks of like it will keep an assumption of all the features are independent and it is not much affecting of one feature to another feature, but in real time we might not get that kind of information. So one or the other way, one feature is dependent on another feature, one feature is going to affect another feature. So that is what another disadvantage or the cons of naive-Bayes algorithm. Okay, so that is how so that's all what it is. These are all what your the pros and cons of naive-Bayes algorithm. Okay, so this is how naive-Bayes algorithm going to work out. Okay, so let us take a simple example and implement naive-Bayes logic. Okay, so can we just take iris data set, so which is observed in the previous sessions. We just have the data set here. We create a data set. First we need to import the libraries. Import pandas as pd, and the next thing we have to import the library, so where it is present. So from Scikit-learn dot, so we have a specific library called naive_Bayes. Okay, here we can import Gaussian NB, which is the library. Okay, so I'll tell you so what is this Gaussian NB and all. Okay, first we need to import the library, so naive-Bayes algorithm. Next, so Gaussian NB is what your naive-Bayes classifier. Okay, so next step it is creating the data set. Okay, so how we are going to create the data set? So let me just create a data set which is saying like one simple example ತಗೊಳ್ಳೋಣ. Okay, what is that? So email classification data set ಅನ್ಕೊಳ್ಳೋಣ. Okay, so I'll just take a very simple data set. Okay, so when an email contain word free or word offer or word win, so the frequencies, so ಇದ್ರ ಬೇಸ್ ಮೇಲೆ ಅದು ಸ್ಪ್ಯಾಮ ನಾಟ್ ಸ್ಪ್ಯಾಮ ಅಂತ ಅನ್ನೋದನ್ನು ಸೊ ಐಡೆಂಟಿಫೈ ಮಾಡ್ಕೊಳ್ಳೋದು. Okay, so let's just created data set is equal to, so okay, so this is what my data set. So how this is present? Okay, so when the word free is there, word win is there, or word offer is there, so then that will be considered as the spam. Like free ಅಂತಿತ್ತು, win ಅಂತ ಇತ್ತು ಅಂದರೆ ಯೂಶಲಿ ಸ್ಪ್ಯಾಮ್ ಅಂತ. ಇಲ್ಲ ಫ್ರೀ ಅಂತ ಇತ್ತು ಆ್ಯಂಡ್ ಆಫರ್ ಅಂತ ಇತ್ತು, ಸೊ ಆಫರ್ಗಳಿದ್ದಾಗ ನಮಗೆ ಫ್ರೀ ಅಂತ ಕೊಡೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಸೊ ಆ್ಯಂಡ್ ಅದರಲ್ಲೂ ನಮಗೆ ಲಿಂಕ್ಸ್ ಇರೋದು. ಸೊ ಈ ಥರ ನನಗೆ ಮೆಸೇಜಸ್ ಅಂತ ಬಂದಾಗ ಆ ಮೆಸೇಜಸಲ್ಲಿ ಈ ಥರ ವರ್ಡ್ಸ್ ಇತ್ತು ಅಂದರೆ ಸೊ ಅದನ್ನು ಯಾವ ಥರ ಕೆಟಗರೈಸ್ ಮಾಡಿದೆ. ಇಟ್ಸ್ ಇಸ್ ಜಸ್ಟ್ ಅ ಸ್ಯಾಂಪಲ್ ಐ ಆಮ್ ಟೇಕಿಂಗ್. ಸೊ ದಿಸ್ ಕೈಂಡ್ ಆಫ್ ಇನ್ಫಾರ್ಮೇಷನ್ ವಿ ಡೈರೆಕ್ಟ್ಲಿ ಸಿಗೋದಿಲ್ಲ. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ರೀಪ್ರಾಸೆಸ್ ಇಟ್ ಮೆನಿ ಸ್ಟೆಪ್ಸ್ Okay, so I have just for the implementation, so I have taken the simple information here. Okay, so when the word free is present in the mail and when is present in the mail, when both are present, so it is a spam. When word free is there, like any like both ಎರಡು ಇತ್ತು ಅಂದರೆ ಯಾವುದಾದ್ರೂ ಎರಡು ವರ್ಡ್ಸ್ ಇತ್ತು ಇದರಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರೆ that means it is a spam. When any one is there, ವಿನ್ ಅಂತ ಇತ್ತು ಅಥವಾ ಆಫರ್ ಅಂತ ಇತ್ತು ಅಥವಾ ಫ್ರೀ ಅಂತ ಇತ್ತು, ಯಾವ್ದಾದ್ರು ಒಂದು ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಸೊ ಅದರಲ್ಲಿ ಫ್ರೀ ಅಂತ ಬರೋವೆಲ್ಲ ತುಂಬ ನಮಗೆ ಸ್ಪ್ಯಾಮೇ ಇರುತ್ತೆ. ಹಾಗಾಗಿ ಸೊ ಅದು ಬಂದಿದೆ ಅಂದರೆ ದಟ್ ಬೈ ಡಿಫಾಲ್ಟ್ ಅವ್ರು ಸ್ಪ್ಯಾಮ್ ಅಂತಲೇ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ತೀವಿ. ಬಟ್ ವಿನ್ ಆ್ಯಂಡ್ ಆಫರ್ ಅಂತ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, ಸೊ ಇಟ್ ಮೈ ಬಿ ಬಿಕಾಸ್ ಆಫ್ ಎನಿ ಡಿಸ್ಕೌಂಟ್ಸು ಅಥವಾ ಅವ್ರದ್ದೇನೋ ಸೆಲೆಬ್ರೇಷನ್ಸು ಪರ್ಟಿಕ್ಯುಲರ್ ಶಾಪ್ದು ಅಥವಾ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಂಪ್ನಿದು ಈ ಥರದ್ದಿದ್ದು ನಮಗೆ ಸಿಗ್ಬೋದು. ಓಕೆ, ಅಥವಾ ಪರ್ಟಿಕ್ಯುಲರ್ ಡ್ಯೂರೇಷನ್ವರೆಗೂ ಮಾತ್ರ ಅವೈಲೇಬಲ್ ಇದೆ ಈ ಥರ ನಮಗಿದ್ದಾಗ, ಸೊ ದಟ್ ವಿಲ್ ನಾಟ್ ಬಿ ಕನ್ಸಿಡರ್ಡ್ ಯೂಶಲಿ ಆಸ್ ದ ಸ್ಪ್ಯಾಮ್ ಮೇಲ್. Okay, so let me just take this data set and we'll just create it, and we have created a data frame. Okay, so adadmele, okay, sorry, okay, so let us just data set create ಆಯಿತು. ಕ್ರಿಯೇಟ್ ಆಗಿದ್ಮೇಲೆ ಸೊ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಸೊ just split the features in split features and target. Okay, ಹೇಗೆ x and y. Okay, so x is equal to, so it is actually df dot I log of, or else I can just directly go for splitting df of free win, directly specifying the columns. When we have very limited columns, when very few columns, then you can directly go for specifying the names. So otherwise if you have too many columns, you can just go for specifying the locations. Okay, index values na use ಮಾಡ್ಕೊಂಡು split ಮಾಡ್ಕೋಬಹುದು. Okay, so this is how we can split it. Next we can directly go for main implementing the model. So model call and model training we can do directly, since this is very simple data set. Okay, so train the model again. So my model is equal to, we have used Gaussian NB. Okay, just need to create an object because that is already previously imported. So next, model dot fit of x comma y. Model got trained, so model train up ಆಯಿತು. Okay, next it's time to find out the accuracy. So for that we just need to predict the y. So predict the results. Model dot predict of, so you can just have the new sample. Predictions na ಮಾಡಬಹುದು ನಾವು. So when we have mail containing free and no win but offer is present. Okay, so ಅದರ value ಇದೆ, yes already ಇದೆ. Okay, so then what is the probability, sorry, what is the prediction? So array of 1 means it is a spam mail. Okay, so this sequence you can observe. Okay, so let me just try with a new one. So it is also spam. So it is not a spam. Array of 0 ಬರ್ತದೆ ಅಂದರೆ that means it is spam or not. ಇಲ್ಲಿ ಬರ್ತಿರೋಂಥ ವ್ಯಾಲ್ಯೂಸ್ 0 ಇದ್ದರೆ ನಾಟ್ ಅ ಸ್ಪ್ಯಾಮ್, ಸೊ 1 ಇದ್ದರೆ ಸ್ಪ್ಯಾಮ್ ಅಂತ. ಓಕೆ, ಸೊ ಫ್ರೀ ಅಂತ ಬರ್ತಿದೆ ಅಂದರೆ ಯೂಶಲಿ ಫ್ರೀ ಅನ್ನೋ ಕೀವರ್ಡ್ ಇಲ್ಲಿ ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಸೊ ಫ್ರೀ ಅಂತ ಬರ್ತಿದೆ ಅಂದರೆ ಸೊ ಇಟ್ ಈಸ್ ಸ್ಪ್ಯಾಮ್ ಅಂತಾನೆ. ಅದಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಆಲ್ಮೋಸ್ಟ್ ನಿಮಗೆ ನಾಟ್ ಸ್ಪ್ಯಾಮ್ ಅಂತಲೇ ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ಯು ಕ್ಯಾನ್ ಪ್ರೆಡಿಕ್ಟ್ ದ ರಿಸಲ್ಟ್ಸ್ ಫ್ರಮ್ ದ ಮಾಡೆಲ್. ಓಕೆ, ಸೊ ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ಚೆಕ್ ಔಟ್ ದ ಅಕ್ಯುರಸಿ. ಅಕ್ಯುರಸಿ ಕೂಡ ಚೆಕ್ ಮಾಡ್ಬೋದು. ಸೊ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಗೋ ಫಾರ್ prediction result. Okay, so use y underscore prediction is equal to model dot predict. So you can just directly go for predicting values of x. Okay, so now accuracy is accuracy underscore score y underscore test. Okay, so y comma y underscore predict we have directly given. So this is also giving 100% result. Okay, so this is how we can check out for the accuracy of the model. Okay. Okay, so this exactly how naive Bayes learns and the world probabilities, and we're going to find out the result. Okay, so usually when naive Bayes is used means, so ಕಾಮನ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಯಾವಾಗ ಬರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಯೂಶಲಿ ಸೊ ಇಮೇಲ್ ಸ್ಪ್ಯಾಮ್ ಫಿಲ್ಟ್ರಿಂಗ್ ಮಾಡಬೇಕಾದ್ರೆ, ಸೆಂಟಿಮೆಂಟ್ ಅನಾಲಿಸಿಸ್ ಅಂತ ಮಾಡಬೇಕಾದ್ರೆ, ಅಥವಾ ಡಾಕ್ಯುಮೆಂಟ್ ಕ್ಲಾಸಿಫಿಕೇಷನ್ಸ್ ಮಾಡ್ತಾ ಇರ್ತೀರ. ಸೊ ಈ ಯಾವ ಕ್ಯಾಟಗರಿ ಇರೋದು, ಯಾವ ಟೈಪ್ ಆಫ್ ಡಾಕ್ಯುಮೆಂಟ್ ಅಂತ ಅಂದಾಗ, ಆ್ಯಂಡ್ ಈವನ್ ಫಾರ್ ದ ನ್ಯೂಸ್ ಕ್ಯಾಟಗರೈಸೇಷನ್, ಸೊ ಫೇಕ್ ನ್ಯೂಸ್ ಆರ್ ಜೆನ್ಯೂನ್ ನ್ಯೂಸ್ ಅಂತ ಇದ್ದಾಗ, ಸೊ ಈ ಥರ ಇದ್ದಾಗ ಯೂಶ್ವಲಿ ನಾವು ನೈವ್ ಬೇಸ್ನ ಸೊ ತುಂಬ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಸಿನ್ಸ್ ಇಟ್ ಈಸ್ ಫೈಂಡಿಂಗ್ ದ ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಪ್ ಆಫ್ ವರ್ಡಿಂಗ್ಸ್ ಅಂಡ್ ಆಲ್ಸೋ ವರ್ಡ್ ಪ್ರಾಬಬಿಲಿಟೀಸ್ನ ಇದು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತಿರೋದ್ರಿಂದ. ಸೊ ದೀಸ್ ಆರ್ ಆಲ್ ದ ಪ್ಲೇಸಸ್ ವೇರ್ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ನೈವ್ ಬೇಸ್ ಅಲ್ಗಾರಿದಮ್. Okay, so companies like Google use the naive Bayes historically for spam filtering in Gmail. Okay, so the Gmail ನಿಮ್ಗೆ ಕ್ಲಾಸಿಫೈ ಆಗುತ್ತಲ್ವ ಸ್ಪ್ಯಾಮ್ ಅಥವಾ ನಾಟ್ ಸ್ಪ್ಯಾಮ್ ಅಂತ ನಿಮ್ಗೆ ಬೇಗನೆ ಅಲರ್ಟ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಸೊ ದೇರ್ ಗೂಗಲ್ ಈಸ್ ಯೂಸಿಂಗ್ naive Bayes. Okay, so that's how you can implement and you see the different applications of naive Bayes. Okay, so let me just give you one thought. Okay, so how to build a basic model using naive Bayes. Okay, so there are different types of naive Bayes algorithm. So ಇಲ್ಲಿ ನಿಮಗೆ ಮಾಡುವಾಗಲೇ ಹೇಳ್ತೀವಿ, ಇಲ್ಲಿ ಗಾಷಿಯನ್ NB ಅಂತ ತೊಗೊಂಡಿದ್ದೀವಿ. ಸೊ ಏನಕ್ಕೆ ಅಂತ, ಓಕೆ, ಸೊ ಒಂದು just a thing, right? So we have different types of naive Bayes. So what are all those? So naive Bayes ಅಲ್ಲಿ ನಮಗೆ ಮೇಜರ್ಲಿ 5 ಟೈಪ್ಸ್ ಇದೆ. ಸೊ ದೇ ಆರ್ 5 ಟೈಪ್ಸ್ ಆಫ್ naive Bayes ಮಾಡಲ್ಸ್ ಆ್ಯಂಡ್ Scikit-learn ಲೈಬ್ರರಿ, ಎಸ್ಪೆಷಲಿ ಪೈಥಾನಲ್ಲಿ ಇರೋದು. Okay, so we have library support to build this algorithm. Okay, we have different types here. So one we have mentioned here is Gaussian naive Bayes. So Gaussian naive Bayes is used in the classification task, and it assumes that feature values follow the Gaussian distribution. Okay, so feature values ಎಲ್ಲ ಏನಿದೆ ಅವು Gaussian distribution ಥರ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದೆ ಅನ್ನೋದನ್ನು ಅಸಂಪ್ಷನ್ ಇಟ್ಕೊಂಡು ವ್ಯಾಲ್ಯೂಸ್ನ ನಮಗೆ ಯೂಶ್ವಲಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸು ಪ್ರಾಬಬಿಲಿಟೀಸ್ ಎಲ್ಲ ಮಾಡುತ್ತೆ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಒನ್ ಇಟ್ ಈಸ್ multinomial naive Bayes ಅಂತ. Okay, so let me just write this. Okay, so multinomial naive Bayes, this it is used for discrete counts. Multinomial naive Bayes ಅಂದರೆ ಯಾವಾಗ ನಿಮಗೆ ಮಲ್ಟಿಪಲ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಿತ್ತು ಅಂದಾಗ. ಸೊ ಲೆಟ್ಸ್ ಸೇ ವಿ ಹ್ಯಾವ್ ಅ ಟೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಪ್ರಾಬ್ಲಮ್. ಸೊ ಹಿಯರ್ ವಿ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಸೊ ಬರ್ನಾಲಿಸ್ ಟ್ರಯಲ್ಸ್ ಅಂತ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ವಿಚ್ ಇಸ್ ಒನ್ ಸ್ಟೆಪ್ ಫರ್ದರ್. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ವರ್ಡ್ ಅಕರಿಂಗ್ ಡಾಕ್ಯುಮೆಂಟ್ಸ್, ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ವರ್ಡ್ ಎಷ್ಟು ಟೈಮ್ಸ್ ಅಪಿಯರ್ ಆಗಿದೆ ಅಥವಾ ಪ್ರಾಬಬಿಲಿಟಿ ಜಸ್ಟ್ ವರ್ಡಿಂದ ಅಷ್ಟೇ ನೋಡಿದ್ದಾನೆ, ಸೊ ಎಂಟೈರ್ ಡಾಕ್ಯುಮೆಂಟಿಂದ ನೋಡ್ತೀವಿ. ಸೊ ಅವಾಗ ಅದನ್ನು ಬರ್ನಾಲಿಸ್ ಟ್ರಯಲ್ಸ್ ಅಂತ ಒಂದು ಮೆಥಡ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫೈಂಡ್ how we have count how often the word occur in a particular document. Okay, and thereby we are going to find out like the result, whether it is a particular type of document or not. So we have multinomial classes are there. Okay, so there we can use like discrete counts ಇತ್ತು ವ್ಯಾಲ್ಯೂಸ್ ಅಂದಾಗ ನಾವು ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕಂತಿದ್ದಾಗ ಯೂಶಲಿ ಸೊ ಈ ಅಲ್ಗಾರಿದಮ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಬಂದ್ಬಿಟ್ಟು ಬರ್ನಾಲಿಸ್ ನೇವ್ ಬೇಸ್ ಅಂತ. ಸೊ ಬರ್ನಾಲಿಸ್ ನೇವ್ ಬೇಸ್ ಮಾಡೆಲ್, ಸೊ ಇಟ್ ಯೂಸಸ್ ಲೈಕ್ ಬೈನಾಮಿಯಲ್ ಮಾಡೆಲ್ ಅಂತ ಹೇಳ್ತೀವಿ ಯೂಶಲಿ. ಸೊ ಲೈಕ್ ಇದನ್ನ ಯೂಶಲಿ NLPಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಅಂದರೆ ನ್ಯಾಚುರಲ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಪ್ರಾಸೆಸಿಂಗ್. ಸೊ ವಿಚ್ ವಿಲ್ ಪ್ರಾಸೆಸ್ ದ ನ್ಯಾಚುರಲ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಆ್ಯಂಡ್ ಇಟ್ ವಿಲ್ ಹೆಲ್ಪ್ಸ್ ಅಸ್ ಟು ಐಡೆಂಟಿಫೈ ಲೈಕ್ ಸೆಂಟಿಮೆಂಟ್ ಅನಾಲಿಸಿಸ್ ಅಂತ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳಲ್ಲಿ ಅಥವಾ ಯೂಶಲಿ ಫೇಕ್ ನ್ಯೂಸ್ ಅಂತ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳಲ್ಲಿ ಯೂಸ್ ಮಾಡಬೇಕಾದ್ರೆ. ಸೊ ಅಲ್ಲಿ ನಾವು ಮಲ್ಟಿಪಲ್ ಎಮೋಷನ್ಸ್ನ, ವರ್ಡ್ ಕೌಂಟ್ಸ್ನ, ಅದರ ಇಂಪಾರ್ಟೆನ್ಸ್ನ, ಅದರ ಪ್ಲೇಸ್ ಆಫ್ ಯೂಸೇಜ್ ಎಲ್ಲದನ್ನು ನೋಡಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಸೊ ಲೈಕ್ ವಿ ಹ್ಯಾವ್ ಅ ಟೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಿಫಿಕೇಷನ್ ಅಂತ ಮಾಡಬೇಕಾದ್ರೆ ವಿ ಹ್ಯಾವ್ ಅ ಮಾಡೆಲ್ ಕಾಲ್ಡ್ ಎಸ್ ಬ್ಯಾಗ್ ಆಫ್ ವರ್ಡ್ಸ್ ಮಾಡೆಲ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಆ ಮಾಡೆಲ್ನ ಯೂಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಇದನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಡೋಂಟ್ ವರಿ ಮಚ್, ಲೈಕ್ ತುಂಬ ಇದು ಅರ್ಥ ಆಗ್ತಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಕನ್ಫ್ಯೂಸ್ ಆಗೋದೇನು ಬೇಡ. ಇಟ್ ಈಸ್ ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಲೈಕ್ ಎಲ್ಲೆಲ್ಲಿ ಯಾವ ಥರ ಅಪ್ಲಿಕೇಶನ್ಸಲ್ಲಿ ಇದನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂತ. ಸೊ ಕಾಮನ್ ಆಗಿ ನಾವು ಗಾಷಿಯನ್ ಆ್ಯಂಡ್ ಬೇನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಮಲ್ಟಿನಾಮಿಯಲ್ ನೇಬೇಸ್ ಅಂದರೆ ಮಲ್ಟಿಪಲ್ ಕ್ಲಾಸಿಫಿಕೇಷನ್ ಮಾಡುವಾಗ ನೇಬೇಸ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡೇ ಮಾಡ್ತೀವಿ. ಅಲ್ಲೂ ಪ್ರಾಬಬಿಲಿಟಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೊಂಡೇ ಮಾಡಬೇಕು ಅಂತಿದ್ದಾಗ ಅಲ್ಲಿ ಮಲ್ಟಿಪಲ್ ಕ್ಲಾಸಸ್ ಇದೆ ಅಂದಾಗ ನಾವು ಯೂಶಲಿ ಲೈಕ್ ನೇಬೇಸ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸ್ಪೆಸಿಫಿಕಲಿ ಒಂದು ವರ್ಡ್ ಡಾಕ್ಯುಮೆಂಟಲ್ಲಿರೋ ವರ್ಡನ್ನು ಅನಲೈಸ್ ಮಾಡಬೇಕು ಅಂದಾಗ, ಸೊ ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡಬೇಕು ಅದು ಯಾವ ಥರ ವರ್ಡ್ಸು ಆ ಥರ ಅಪ್ಲಿಕೇಶನ್ಸಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಟೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಿಫಿಕೇಷನ್, ಸೊ ಯಾವ ಥರ ಕ್ಲಾಸ್ ಆ್ಯಕ್ಚುಲಿ ಅಂದರೆ ಯಾವ ಟೆಕ್ಸ್ಟ್ ಇದು, ಆಲ್ಫಾಬೆಟ್ಸ್ ಯಾವುದಿದು, ಈ ಥರ ಇದ್ದಾಗ ಯೂಶಲಿ ಮಲ್ಟಿನಾಮಿಯಲ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಬರ್ನಾಲಿಸ್ ನೇಬೇಸ್ ಯಾವಾಗ ಅಂದರೆ ಡಾಕ್ಯುಮೆಂಟ್ ಲೈಕ್ NLP ಯೂಸ್ ಮಾಡುವಾಗ ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ಓಕೆ, ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ಇಟ್ ಈಸ್ ಕಾಂಪ್ಲಿಮೆಂಟ್ ನೇಬೇಸ್ ಮತ್ತು ಕ್ಯಾಟಗಾರಿಕಲ್ ನೇಬೇಸ್ ಅಂತ. ಸೊ ಲೆಟ್ ಮಿ ಜಸ್ಟ್ ಹ್ಯಾವ್ ದೀಸ್ ಟೈಪ್ಸ್ ಹಿಯರ್. ಥರ್ಡ್ ಟೈಪ್ ಬಂದ್ಬಿಟ್ಟು ಬರ್ನಾಲಿಸ್ ನೇಬೇಸ್. ಫೋರ್ತ್ ಟೈಪ್ ಬಂದ್ಬಿಟ್ಟು ಕಾಂಪ್ಲಿಮೆಂಟ್ ನೇಬೇಸ್ ಅಂತ. ಫಿಫ್ತ್ ಟೈಪ್ ಬಂದ್ಬಿಟ್ಟು categorical ನೇಬೇಸ್ ಅಂತ. ಓಕೆ, ಸೊ ದೀಸ್ ಆರ್ ದ 5 ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ನೇಬೇಸ್ ಅಲ್ಗಾರಿದಮ್ಸ್. ಕಾಂಪ್ಲಿಮೆಂಟ್ ನೇಬೇಸ್ ಯಾವಾಗ ನಮಗೆ ಇಂಬ್ಯಾಲೆನ್ಸ್ಡ್ ಡಾಟಾ ಇತ್ತು ಅಂದಾಗ. ಓಕೆ, ಸೊ ನಮ್ಮ ಡಾಟಾ ಇಂಬ್ಯಾಲೆನ್ಸ್ಡ್ ಯೂಸ್ ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಲಾಸ್ಟ್ ಒಂದು ಬಂದ್ಬಿಟ್ಟು ಕೆಟಗಾರಿಕಲ್ ನೇಬೇಸ್. ಕೆಟಗಾರಿಕಲ್ ನೇಬೇಸ್ ಯಾವಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಸೊ ಯೂಸ್ಫುಲ್ ವೆನ್ ದ ಫೀಚರ್ಸ್ ಆರ್ ಕೆಟಗಾರಿಕಲಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್. ಓಕೆ, ಫೀಚರ್ಸು ಯಾವಾಗ ಕೆಟಗಾರಿಕಲ್ ಇತ್ತು ಅಂದರೆ ಟೆಕ್ಸ್ಟ್ ಫಾರ್ಮ್ಯಾಟ್ಸಲ್ಲಿ ಕೆಟಗಾರಿಕಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಇತ್ತು ಅಂದಾಗ ಮೇನ್ಲಿ ಇದನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇದು ಯಾವಾಗ ಇಂಬ್ಯಾಲೆನ್ಸ್ಡ್ ಡಾಟಾ ಇತ್ತು ಅಂದಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಬರ್ನಾಲಿಸ್ ಯಾವಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಸೊ ವಿ ಯೂಸ್ ಟು ಹ್ಯಾವ್ ದಿಸ್ ವೆನೆವರ್ ವಿ ಹ್ಯಾವ್ ಅ ಲೈಕ್ document type of sorry, you can use like NLP in short. Okay, so this will be used text classifications anta banda. Okay, so in Gaussian and we move to general standard method. By default. Okay, so these are the different types of naive-based algorithms. So we can implement. Please mute yourself if you are used somewhere. Okay, so this is how you can implement naive-based classifier. Okay, hope it is understood. So don't bother much about the different types here. You just need, you have the library support, you can have the different functions and methods available here, and you can just simply call them and you can use them, but be aware where it is used. ಓಕೆ, ಸೊ ಯಾವ ಥರ ಪ್ರಾಬ್ಲಮ್ಸಿಗೆ ಅದನ್ನು ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅನ್ನೋದನ್ನು ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಆ್ಯಂಡ್ ಪ್ರಾಪರ್ ಸ್ಪೇಸಲ್ಲಿ ಅದನ್ನು ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಕೆ, ಸೊ that is how naive Bayes algorithm going to work. Okay, so that's what it is. So that's about the different random forest algorithm and the naive Bayes algorithms. So, okay, so if you have any doubts, you can ask me.